So today we're going to continue working with our inequalities that we started yesterday and the day before. Now, the last couple of classes, though, all we were doing was graphing. We decided if we had a dotted or solid line, we drew our line, we tested an ordered pair to see if it was a solution, and then we shaded. Today we're going to keep building off that, and we're going to do some application piece. I know for some of you, like, application, Miss Guy, what do you mean by that? For you guys, it means word problems. That's usually about how it gets interpreted. So let's take a look at our first one. It says teenagers should consume at least 1,200 milligrams of calcium per day. Suppose you get calcium from two different sources, skim milk and cheddar cheese. 1 cup of skim milk supplies us with 296 milligrams of calcium. 1 slice of cheddar cheese supplies us with 338 milligrams of calcium. What phrase in this opening question, before I move on to anything else, is going to indicate to us that this is going to be an inequality without my having to tell you it's going to be one? What little phrase? What do you think? At least, yeah. That little phrase, at least, is telling me this is going to be an inequality. So let's take a look. Letter A, it says write an inequality that represents the amounts of skim milk and cheddar cheese you need to consume to meet your daily requirement of calcium. Now, I didn't specifically put it in here, but you need to define your variables. So if you're using X and Y, I want you to write down what X represents and what Y represents. Now, since we're using inequalities, we know we have to graph. We're going to have to graph and shade. That's how we solve inequalities. Whether there's one variable or two variables, it's how we solve inequalities. We graph and we shade. So, let's use, I like to use X and Y for my variables, since we're graphing. You don't have to. If you want to use S for skim milk, or C for cups of skim milk, or C for the cheese, that's fine. That's fine. I like to use X and Y because it helps me graph. So let's let X equal cups of skim milk. Cups of skim milk. I want you to be very specific. I'm not going to ask a lot of problems of you today. I'm going to ask 4 problems of you today. So the 4 that we do, I want us to do them well. I want us to be very detailed with things. Don't take shortcuts. That's why I minimize the number of problems, so we have a small amount of problems that we can do well. So X is cups of skim milk. Then the Y is going to be, we have slices of cheddar cheese. That's what we've got. Those are our 2 things we're looking for. If you're like, Miss Golly, I don't see that question mark though, like we had last unit. I always looked for that question mark, and that's how I knew the 2 things. If we take a look at letter A, it says write an inequality that represents the amounts of skim milk and cheddar cheese. So in letter A, in the actual directions with letter A, I'm telling you the 2 things you need. So make sure you read letter A very carefully. So now we have to write our inequality. We're going to use X and Y just because we know we have to graph. And using X and Y, I think, makes graphing a little bit easier. So now we have to actually write the inequality. How many milligrams of calcium do we get from a cup of skim milk? How many do we get? Let's see. 1 cup supplies 296. So 296 milligrams for every cup of skim milk. 296 milligrams of calcium for every cup of skim milk. Now, in addition to that, we had our 1 slice of cheddar cheese, 338. So 338 milligrams every slice of cheese. X is cups of milk, Y is slices of cheese. Now, we know we want to get at least a total of 1,200. I don't want us to have to memorize. I know we kind of boxed up that phrase at least. At least told us, hey, it's going to be an inequality. I don't want us to have to memorize if that means greater than or if that means less than or what that means. Let's think about it this way. If I need at least 1,200, Is 1200 the most I need or the smallest I need? Smallest, bare minimum. We've been talking a lot that our symbol opens to the bigger number. So if 1200 is the least amount I need, it's the bare minimum I need, my symbol is going to open the other way. So I'd rather have us reasoning our way through this, thinking about 1200, is it the most or is it the least, and what that means for our symbol, versus trying to memorize that at least means it's a greater than, or it can be equal to. It says at least 1200, so 1200 is going to be okay. 1200 is going to be okay. So we have our variables defined very specifically. I didn't just put milk and cheese. I put cups and I put slices. So we defined our variables very, very specifically. We wrote our inequality. Our next task is to graph. So when we graphed yesterday, the first thing we decided was, are we going to have a dotted or solid line? Which one's this going to be? What do we think? Dotted or solid? Solid. How do I know it's solid? How do I know it's solid? Because there's a line under it. There's an equal to. So it's going to be a solid line. And what form do I have? Slope intercept or standard? Standard. How do I know it's standard? We've got x and y are on the same side. So we're going to have a solid line and we're going to have standard form. Those were the two things we picked out yesterday before we graphed. Now, since we have standard form, I always like to draw my little chart. Take it or leave it on the chart. It's up to you. When we have standard form, I know this is one that we reviewed yesterday and the day before, but standard form seems to be the one we still keep getting stuck with the most, so I wanted to make sure that's what we went through today and got a little more practice with today. So we want to use our x and y intercepts to graph. So I know most of you out there, you like to put 0 in for x first. You like to find your y-intercept first. So we have 296, put a 0 in for x. Show as much work on this as you need to. Now instead of that greater than or equal to sign being there, when you go to find intercepts, just make it an equal sign. Don't worry about being greater than, less than, just put an equal sign. We're just looking for intercepts. So we don't need to get bogged down with that. 296 times 0, well, that's just 0. Trying to save us a little bit of space here, a little bit of writing. So we end up with, we have 1200 divided by 338. And I get 3.55029 and it keeps going. So I'm going to round that off. I'm going to call it 3.6. Let's just go to the nearest tenths when we round. This graph for us, it's just going to be a sketch with that boundary line. If we want the exact line, we'd have to use some form of technology. All right, so we've got our y equals roughly 3.6-ish. So now we do the same thing, except we put 0 in for y. So 296, we leave the x. 338 times 0. 338 times 0 is just 0. And then we divide. Now this one I don't think is going to work out very pretty either. 1200 divided by 296. Our x is roughly, it's going to round to about a 4.1. And this is oftentimes the case when you do application problems. If you actually grab real numbers, like you need 1200 milligrams and there's actually 296 milligrams of calcium in a cup of skim milk, when you start actually using real world numbers, things don't always work out pretty like our graphs yesterday. We usually end up with some decimals or fractions or things. All right, so let's graph our line. In order to do that, we need to label our graph a little bit. Our graph looks a little different from yesterday. We just need that top right quadrant. We don't need all 4 quadrants, because if we're talking cups of milk and slices of cheese, I just need everything positive. I can't have negative cups of milk. I can't have negative slices of cheese. So we need to keep everything positive. So that's why you just see that top quadrant 1 on your paper, that top right quadrant. That's all we need. Now, since it is application though, we want to be specific with things. We want to be detailed. We want to label our axes. So if my x-axis is down below, what do my x values represent? What did we label them as? What did we label the x's as? Cups of skim milk. So this is cups of skim milk. And then the y, we had slices of, if you just want to put cheese, you can. I'm going to be specific and put cheddar cheese. Up to you. And it looks like we just need to be able to fit where the y is a little over 3 and the x is a little over 4. So that means it's safe for us to just have a scale of 1s. If you're using a scale of 1s, I'm not going to be super picky if you take the time to label each little increment on there. If you're going by 1s, you can label it if you want to. That might help you with your ordered pairs and your testing later. But I'm going to kind of leave that part up to you. If you decide to use a bigger or smaller scale, then you do have to label. If you don't put any numbers on your axes, I just assume that you're going by 1s. All right, so we've got our graph labeled. Now we need to graph our intercepts. We had that y was 3.6. So on the y-axis, I need to go 1, 2, 3, and then 0.6, that's just a little bit more than a half. And you do the best you can with that. You do the best you can. I know by the time the boxes are so small, by the time you actually draw a point on there, you've taken up most of the box anyway. That's why this is a sketch. And then our x value was 4.1. So I go 1, 2, 3, 4, and then just a little bit more on the x. Remember that x value is an x-intercept. It's not a slope. When we graph in standard form, we get a point on the y-axis, we get a point on the x-axis, and then we take our straight edge and we connect them. And mine's not super straight. They never are up here. That's pretty good. And we set a solid line. Make sure you be careful with your dotted and your solid. There will be some that are dotted today. All right, now since it's an inequality, we have to find our solutions to shade. Easiest point in the world to test is 0, 0. So let's test. I think I have room right here. Test 0, 0. Easiest point in the world to test. 0, 0. Now how much work you show for this is up to you. I want to show you the actual substituting in. But if this is something that you're just checking using the calculator, you know what? I'm going to be okay with that. This whole left-hand side, you can put that whole thing in the calculator if you're unsure what that equals. Put it in the calculator, parentheses and all. But this is a big reason why we picked 0, 0, because 296 times 0 is just 0. 338 times 0 is 0. That's why we say 0, 0. One of the reasons why we say 0, 0 is so easy to use. Because if I multiply with it, I just get a bunch of zeros. Makes life a little easier. So this testing piece, this was fairly new for us the last couple days. I put in 0, 0, and I end up with 0 is greater than or equal to 1200. Is that true or not? What do you think? 0 is greater than or equal to 1200. Does that work? No. That's a false. That doesn't work. So 0, 0 is down here in that bottom corner on the bottom side of the line. 0, 0 is not a solution. So where do I shade? Do I shade where 0, 0 is down here, or do I shade the other side? Other side. And when you do your shading, you don't have to get too crazy with it. I mean, you don't have to get every little perfect little thing in there. We get the idea. So the graphing part is not new for us. The graphing part's not new. But now what we do with that graph is the next step. So here's the next piece. Letter C. Letter C, it says identify and interpret two different solutions. So if I look at my graph, where do I find solutions at? What did we do with the solutions? Where are they? What do we think? Where are the solutions at on my graph? Solutions. The solutions are in the shaded space. We shade solutions. So now our job is to pick out any solution we want. So any ordered pair in that shaded space will work. So for example, I just heard 4, 4. Is 4, 4 in the shaded space? Yeah, 4, 4 is in the shaded space. So that means 4, 4 should be a solution. It should make my inequality true. And I highlighted it with that, whoops, sorry guys. I highlighted it with that red dot right there. So 4, 4. I'm going to test it out. 296 times 4, 338 times 4. Is that greater than or equal to 1200? I want to make sure it is a solution. So this is kind of our double check to make sure we shade it the right way. You can take the entire left-hand side and put it right in your calculator. You don't even have to do it piece by piece. Use the parentheses if you need to. And I get 2,536. Did 4, 4 work? Is 4, 4 a solution? Yeah, 4, 4 works. That's true. So that's the identify part. 4, 4 is a solution. It works. Now we need the interpret piece. Interpret just means, hey, label the numbers. We have a 4 and a 4. What do they each mean? So my first 4 for my x, I go back up and I see that x is cups of skim milk. So we have 4 cups skim milk. And then the second 4 for the y, I go back up and I look and I see that y represents slices of cheddar cheese. So that would be the interpret part. So the identify part is, hey, I find an ordered pair in the shaded place and I make sure it works. Then I take my ordered pair and I interpret it. So in other words, I label it. What the heck does each one mean? So this would be one of my solutions. I want you to find 2 because I want us to get a little more practice. This is something we struggled with when we just had our equations last trimester. Not our inequalities, but just our equations. It's something we struggled with when we graphed and I asked you for solutions. Some of us were struggling to find the solutions that were on our line we graphed. So I want us to find 2 each time just so we get in the habit of finding solutions in the shaded space. So we could do, I'm going to do 3, 2. I'm just going to keep my numbers small. The bigger my numbers get, the bigger they are when I multiply and things. You don't have to go huge on the graph. You can go anywhere you want in the shaded space. I picked 3, 2. 3, 2 is in the shaded space. I just want to check it, make sure it works. And again, that left side, you can put right in the calculator. When I do that, I get 1564. It's a smaller number, but it's still bigger than 1200, so we're still in good shape. Now I have to interpret though. I picked out an ordered pair in the shaded space. I checked to make sure it was a solution, and now I have to interpret it, aka I have to label what it means. The 3 is my x. If I need to go back up above to letter A, I do, and I see that x is cups of skim milk. And then my 2 is my y. So again, if I need to, this is why we label our variables. It's why we label our axes. What do our numbers mean? And we got 2 slices, cheddar cheese. All right, so here's the expectation for these problems. All I expect today is that you get finished up through problem 4. So that's only 3 more problems today. So let me make sure I'm clear on the directions. We have a lot of time left for 3 problems. So I expect in letter A, you've defined your variables like I've underlined in red. I expect your axes to have labels like I've underlined in red. I expect to see 2 solutions that are labeled like I put the red boxes around down here. So everything I have up here I need to see on your sheet too. Now it's really tough. It's really tough for you to check yourself to see if your inequality symbol's going the right way. So raise your hand, I will check that for you today. It's also really tough to check to make sure that you in fact graphed your line right. I don't have a double check for that for you or a self-check. So if you need me to today, I can check the way your inequality symbol's pointing, and I can double check how you graphed your line. Because those 2 things you cannot check yourself. They're not a self-check thing. Okay? I can get my inequality symbol backwards, I can graph my line wrong, and I still might come up with things that work. Alright? So those are the things. I'll be more than happy to check anything for you, but those are the 2 big ones that you really can't check yourself. Okay?